In the previous video, we looked at using the trig ratios, sine, cosine, and tangent, to solve right triangles for an unknown side. Now we'll look at how to use them when we want to solve for an unknown angle. The general steps are the same, but there is one new button and function we need to know in order to calculate the angle. Recall that in each of the trig ratios there are three measurements: the angle, in this case labeled capital A, and a ratio of two of the three sides of the triangle. We choose which trig ratio to use, sine, cosine, or tangent, based on the sides that we know or are trying to find out. Let's look at how to solve one of these trig ratios to get the unknown angle by itself. In the next examples, we'll find the missing angles, and at the end we'll round them to the nearest whole degree. The first steps are the same. We need to take a look at our triangle and label it. We're going to label the hypotenuse, opposite, and adjacent sides specifically based on the angle we want to find. So here, if we're trying to find this angle, let's call it A. I can label the side across from that as the opposite side. The side across from the 90 degree is always the hypotenuse. And the other side next to my angle is the adjacent side. Now I'll choose which of the trig ratios to use, and it's going to be based on the two sides that I know, since I need to know those two values to find the unknown angle. In this case, I know the measurement for the hypotenuse and the opposite sides. Looking at the trig ratios, that means I need to use the sine ratio. The sine of angle A is equal to the opposite side over the hypotenuse. Subbing in what I know, the sine of angle A is my unknown. I know the measurement for the opposite side is 19, and the hypotenuse is 27. Now we're going to try and solve for the unknown angle. I could do 19 divided by 27 in my calculator to get a decimal number, but I'm going to do all the calculations all at once. I need to get angle A by itself, and right now it's attached to this sine function. I need to move that sine function to the other side, and just like anything, we do the opposite of the function on the other side of the equals. The opposite of the sine function is called the inverse sine, and it has that symbol sine with this sort of -1 exponent. So when I move the sign across the equal sign, it becomes the inverse sine of that fraction that was already there, 19 over 27. All I need to do now is punch this into my calculator. If you notice, above your sine, cosine, and tangent buttons on your calculator, in orange here are those inverse symbols. Sine with the -1, the inverse sine, cos with the -1, the inverse cos, and inverse tan. To get to those, I use my second function button. So here I hit the second function of sine. It gives me the inverse sine you can see in the screen, and then I'll do a bracket with the fraction 19 divided by 27. You could also use your fraction key here. Close the bracket, equals 44.72. Notice that this angle is in degrees because my calculator is still in degree mode. So to the nearest whole degree, angle A is 45 degrees. Let's take a look at another example. Here we have a ramp with a run of 5 feet and a rise of 9 inches, and we want to find the angle of incline. We can start with a sketch. So again, we have a ramp. The run is the horizontal distance, 5 feet, and the rise is 9 inches, the horizontal distance. We want to find the angle of incline, or angle A here. Notice here that our run is in feet and our rise is in inches. Just like any fraction or percent calculation, before we can substitute those in, they need to be in the same units. So you could choose here to convert both to feet or both to inches. In this case, I'll convert the 9 inches to feet. 9 divided by 12 is 0.75 feet. Now the steps are the same as above. I'll label my triangle across from the 90 degree as the hypotenuse. Across from the angle I'm interested in is the opposite side, and my other side beside that angle is the adjacent side. Again, I know the adjacent and the opposite side, so I pick my trig ratio to use. The trig ratio that has opposite and adjacent in it is tan. So tan of angle A is the opposite side over the adjacent side. Subbing in what I know, tan of angle A is equal to 0.75 over 5, noticing that I'm putting in both of the values in the same units, in this case feet. To get the angle by itself, I move the tan function to the other side. It becomes the inverse function of tan times the fraction 0.75 over 5, and then I go to my calculator. To get the inverse function of tan, I use my second function, tan, and then bracket 0.75 divided by 5 is an angle of 8.53, or to the nearest whole degree, 9-degree incline. So the general steps for solving a trig ratio for the angle are the same as before. We need to label our triangle and put our known values into the proper trig ratio, and then we're isolating the angle in the equation. In order to do that, we need to use these inverse ratios and the second function button on our calculator.